Welcome back to the Hyperbolic Coding Chamber. We are back once again. We don't have any comments today, but I don't think there's much to say anyway. So I think we're just going to jump into it. I think we're going to do a classic 30-minute session. I think we were stuck on a problem. We've still been avoiding projection area because the problem makes no sense, but maybe we'll get to it. Now we're working on range addition. So I think that's going to be what we spend our time working on today. So we have 30 minutes. I tried an supposedly m by n solution, but it's definitely not m by n because you have an x and a y to make the changes within, and then we're going to do x times y operations times the number of ops, which is pretty crazy. There's got to be some range that we can work with since the grid always starts at 0. Presumably, the number of numbers with the number of maximum integers should just be the number of numbers that have been ranged over multiple times. What if instead of xy of ops, we did something like this? We'll say xy comes out of ops sub I. Still getting runtime error though. This is gonna sound nutty, but I feel like you can just... What if we reset the whole thing and we do ops.sort, right, A, B, and we're gonna sort it we'll sort it with a custom comparator, right? So we'll say A minus B is less than 0, right? Actually, we can just say if A equals B, or if A sub 0, right, equals B sub 0, right, then we want to break the tie a different way. But otherwise, we want to return A sub 0 minus B sub 0, right? And then if they're equivalent, then we want to break the tie by sorting on the next value, which would be the Y value. So we'll say return A sub 1 minus B sub 1. Then from here, if we just print ops and return a random number, we should get these sorted in ascending order. From here, we should just be able to return ops sub 0 times ops sub 1. Let's check if ops can be empty. It can. So say if ops dot length equals 0, then we can just return m times n. Wait, this should be 0 sub 0. In fact, maybe a better way might, because I'm assuming that they're always going to be square. If they're not square, maybe it makes more sense to sort by cubes taken up. So instead of sorting by this, we return, right, A sub 0 times A sub 1, right, minus B sub 0 times B sub 1. Actually, if we take the smallest, you skip the sort, and we say the smallest x is equal to ops, or equal to infinity, and we'll say smallest y is also equal to infinity. Smallest x will be equal to the math.min of smallest x and x, and then we'll do the same. Then we should just be able to return smallest x times smallest y. Nice. So I think the smallest formation, you're taking the smallest amount that's ever considered row-wise, column-wise, and then taking the smallest row that's ever considered. And that should be the area that's touched most often. So an image smoother is a filter of the size 3 by 3 that can be applied to each cell of an image by rounding down the average of the cell. Rounding down the average of the cell and the 8 surrounding cells. The average of the 9 cells in the blue smoothing. If one or more of the surrounding cells of a cell is not present, we do not consider it in the average, i.e. the average of the 4 cells in the red smoother. Given an n by n integer matrix image representing the grayscale of an image, return the image after applying the smoother on each cell of it. Image filter of the size 3 by 3 that can be applied to each cell of an image by rounding down the average of the cell and the 8 surrounding cells. One or more of the surrounding cells of a cell is not present, we do not consider it in the average. So if we started in the top left corner with 1, the surrounding average would be, the sum would be 3 divided by 4, which would give you a number less than 0, rounded down, which would give you 0. So all of these would give you get 5 divided by 5 divided by 6, which would give you a number closer to 0 if you round down. So then we could do this by m by n by 9, but if we drop the constant 9, it should just be m by n. So from here, then we could just go through each cell and then we'll have some function calculate the average and apply the smoothing. So we calculate the average of the surrounding 9 cells and then round down. So usually when we do cell, we can create some array of cells which would give us an offset from the current index. That can be up here. We'll call this cell offsets. Then we'll have a cell sum, which is equal to 0. And at the end, we can say that image sub row sub column would be equal to cell sum or the math dot floor of, the math dot floor of cell sum divided by cells available. So we also have another variable called cells. Cell offsets, we're going to check if row plus x offset is within the matrix. To do that, we just have to make sure that row, the maximum row you can have, is if the grid is square. Is greater than or equal to 0, and row plus x offset is less than image dot length. Maybe do the same thing for column. Col plus y offset has to be greater than or equal to 0, and col plus y offset must be less than image sub row dot length. If that's the case, we'll say cell sum plus equal image sub row sub col. In fact, cell sum can start at image sub row sub col. And then it would just need the remaining cell offsets. So we'd have one above us. To get one above us, we would add -1 where the row and the column would stay the same. To get to the top right, we would do -1 and 1. To get to the right of us, we would stay on the same row, but add 1. To get to the bottom right, we would add 1, and also add 1. To get below us, we would add 1 and stay in the same column. To get to the bottom left, we would add 1 and subtract 1. To get behind us, we would do 0 and subtract 1. And then to go up, we'd subtract 1 and also subtract 1. Okay, so I think this should probably actually be plus x offset. So it looks like we're not saving the rotating cell with without the overlapping changing value. So if you do basically like a convolution up here, when you go to the next cell, it shouldn't include the new average values of the previous round, which was not mentioned, but we probably would have saw that if we ran through the examples. So I think we're going to stop there.